Hi everyone, it's the year 3020, and yes, we've got flying cars now, but hyperspace travel still isn't perfect yet, so my sofa is currently floating somewhere in the freezing void of space. This episode is a bit more technical than the first, but we'll keep it partially simple and follow what actually happens when a computer turns on. Let's take a normal computer and put it into our science rig. Now we're going to step through what happens when it powers on. 3, 2, 1, power. Press the on button. Instantly, electricity flows through the system. The CPU wakes up, memory powers on, storage becomes active, even the keyboard and trackpad come online. But right now, the computer doesn't really know what to do yet, so it looks for its very first instruction. Deep inside the computer is a tiny system called the BIOS, which always starts first. You can think of it as the computer's starting guide. It tells everything else how to begin. The computer follows this guide and moves into something called the boot process. First, it checks itself. This is called post, or power on self-test. It makes sure the memory is working, the storage is connected, and nothing important is broken. It's like a quick health check before starting a journey. Then it looks for something important, an operating system. The operating system is the main program that controls everything, like Windows or Linux. Without it, the computer is just hardware that doesn't know what to do. Once it finds the operating system, the computer loads it into memory and hands control over. Now things start to get more organized. Different parts of the computer begin working together. The system sets up memory, prepares files, connects devices, and gets ready to run apps. At this point, the computer goes from just turned on to fully alive. But there's one very important idea that keeps everything safe from this point forward. The computer has two modes, a powerful and restricted mode. The powerful one is called kernel mode, sometimes called supervisor mode, and the restricted one is called user mode. In kernel mode, the system itself is in control. It can access everything. In user mode, normal apps run, but they're limited, so they cannot damage the system or take over during their CPU cycles. If every app had full control, one mistake could crash the computer instantly, so instead, the computer carefully switches between these modes. When an app needs something important that requires kernel mode, like saving a file or using the keyboard, it asks the system for permission through something called a system call. The system decides whether or not to allow it, and then the kernel performs the task and hands control back to the program. This is how computers stay stable even when many programs are running at the same time. So from a single press of a power button, a huge hidden process takes place. The computer wakes up, checks itself, finds its operating system, and builds the rules that keep everything safe. And all of it happens in just a few seconds. What feels instant on the outside is actually a whole hidden process happening step by step inside the machine. That's what makes computers so powerful, but also so reliable. They're not just fast, they're organized. And the more you look inside them, the more you realize. Every click, every app, every screen is built on layers of systems quietly working together.